Today, let's go over a hard grind 75 question called sliding window maximum. This one is pretty self-explanatory in terms of understanding the question at least, but the challenge here is with solving it efficiently. So simply, you're given an integer called k, and you want to slide the window over the array, and the window size being k in each turn from left to right. And then you want to find the maximum value in each window and append that to a result list, which we're going to return. You see the constraints here, meaning that we cannot use brute force to solve this. So we have to think of a more clever way to do this. So if you know how a sliding window works, essentially we start with the first window, we add this element and we remove this element. We add this element and then we remove this element. And we keep doing that until we get to the end. So let's define two pointers. And let's actually define a sorted list that's going to make this more efficient so we can get the biggest value in O of 1 time instead of taking O of n to find, because the max function in Python like this takes O of n time because you have to go through every single element. It's not efficient. The sorted list works its magic. So now let's go through the nums array. And let's say that if length of current is less than k, then cur.add nums of right. And let's print cur to c. If that's not true, then cur.remove nums of left, cur.add nums of left, nums of right, like we said, right? So removing 1, adding -3 to shift the window to the right by 1 position. Let's print current to C. It's not inside of here. Goes to 0. And then let's increment left because right is incremented automatically through this for loop. And let's say if length of current is equal to k, then print current. So cool. So now we have our windows of size k from left to right. And now we can simply just append the last element because we know the sorted list is already sorted. So the last element is going to be the biggest, right? 3, 3, 3, 3, 5, 5, 6, 7. Same here. Sorted list is 1. And then at the end, you can just return the result. Output limit exceeded just means you need to get rid of the print statements. And there you go. So it passes all test cases, and this is O of n, and it's pretty efficient. So hopefully this made sense, and it's very intuitive. I know this is a hard question, so it's good to know that things like the sorted list exist in Python. So thank you for watching. Hit the subscribe button, and stay tuned for more.